Hi, welcome back everybody. So today I am in the mood for doing some homework with you on discrete probability distributions. So let's begin. What are the two requirements for a discrete probability distribution? And it says select all that apply. So let me talk through it. So is it true that the probabilities have to be between 0 and 1? And by now you've been in class or you've read a lot, so you know that's true. Is it true that the sum of all the probabilities in the discrete probability distribution should equal 1? Yes, that's true. By process of elimination, it's not C, and the sum of the probabilities should not equal 0. So we're thinking A and B. Let's check those off. So I had hit pause and actually clicked those two answers, and it says, good job. Probabilities have to be between 0 and 1 inclusive on your probability distribution. And if you're forgetting what the probability distribution looks like exactly, we're going to see that in a moment. And all the probabilities should be between 0 and 1, and the sum of the probabilities should equal 1. Okay, let's take a look at number 2. Determine whether this distribution, now this will trigger your memory, is a discrete probability distribution. Well, the first thing you want to eyeball is these probabilities over here. They're non-negative, okay? And the sum of all the probabilities you want to check is the sum of all the probabilities equal to 1, question mark. And I'll let you take a moment to add that up. So survey says we're probably thinking D. Yes, because the sum of the probabilities is 1, and each probability is somewhere between 0 and 1. Let's click that. And I'll go ahead and see what the computer says. That's the nice part of my math lab. It tells you if you're right. Okay. Many of you are very used to that already. Let's try the next exercise. Okay. This one says determine the required value of the missing probability to make the distribution a discrete probability distribution. So again, your eyeball should go right to those probabilities. You should also look at the variable x. I mean, it's obvious that the variable x takes on clearly separated values, hence a discrete random variable. But here we need to figure out what would we need to make 100%. So, 0.27, 0.20, 0.25, if we add all those together, we got 0.72, so what are we missing? So whatever 1 minus 0.72 is, I'll let you think about that. So we figured that out as 0.28. Computer says good job. And let's try number 4. Another thing that we want to be good at in this chapter is once you have a discrete probability distribution, you can obviously create what's called a probability histogram, and we want to be able to interpret that. So the probability histogram to the right represents the number of live births by a mother 42 to 46 years old who had a live birth in 2012. So what's the probability that a randomly selected mother who had a live birth in 2012 has had her 4th live birth? So, a lot of times people have a tough time, interpreting. So that basically 4th live birth, so 4th child. So it makes sense that the distribution is skewed to the right because, the chance that you're on child number 8, you would think that would go down. Except for then you get into fertility drugs. You see probability actually goes up a little bit at the end. So 11% chance. So we're reading the table 0.113. Let's try that. Let me go there. 0.113. Hit check answer. Okay. Now it's going to keep asking us questions based on this histogram. What's the probability that a randomly selected mother who had a live birth in 2012 has had her 4th or 5th live birth? Now I'm going to underline something there. We know about probability now. 4th or 5th or means union, means add. You're going to be adding two probabilities together. So basically the 0.113 and the 0.108, these two probabilities right here, we're going to add those together. 0.221. Okay, and I figured it would ask us yet another question. What is the probability that a randomly selected mother who had a live birth in 2012 has had her sixth or more live birth? That means she's on her sixth, or she said 6 or more children. There's another way of saying that. So 6 or more, that means we have to add all these. So 0.029, 0.034, I'll write that so you can see those decimals a little better, and 0.044. The main notion is that you're interpreting the question, and we add all those up. So maybe you can see what I typed. So I added up the 0.029, the 0.034, and the 0.044, and I got the 0.107 right here. And then the last one, I gotta love this homework, it keeps asking more and more questions. If the mother who had a live birth in 2012, if a mother who had a live birth in 2012 is randomly selected, how many live births would you expect the mother to have? Aha. Be on the lookout for the word expect. Remember that mu, expected value, is equal to summation x p of x. Well, I'm just going to set this up and let you think about it. So basically each observation times its probability, because we're going to have to do that in the next problem. So basically you're going to take 1 times its corresponding probability plus 2, and see I'm reading this off from here, plus 2 times its corresponding probability, which is 0.274, plus 3 times its corresponding probability, which you see here is 0.163, dot, 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 and do that all the way out till you get to 8, times its corresponding probability, 0.044. I'll let you carry that on. Now I did want to show you, I just typed in a random number just by guessing, like 3.2, but the computer is really fussy. I wanted to show you that. It says round to 1 decimal place. So when you compute that expected value, that formula that I just gave you, summation x p of x, it's very fussy. So, and what's nice about the online homework is it'll tell you you're not correct and make sure you're using the right formula, okay? Now I was just playing with that. I'll let you do the computation. Okay, so now that I showed you the formula and you know that from class, I want to show you kind of a nifty way to get through that calculation a little more easily. So stat, edit. Notice I put, the number of children in L1, 1, 2, 3, 4, 5, all the way to 8. And then what I did was I put the corresponding probabilities in L2. And then to get the expected value, I call it cheating because you're not crunching it out by hand, just hit stat, calc, 1 variable statistics, hit enter, but then tell it L1, comma, L2, and it'll get your mean with regard to that distribution. So CX, the 3.028, so rounded that's 3.0, that's what we're looking for. So let's type that in. Remember, the computer's going to be fussy. See? So now you know how to do that on the calculator to find the expected value. And I wanted to mention, if it asked me for the standard deviation of the distribution, I could pull that from the calculator as well. That would be 1.9, or really close to 2 kids in this case. All right, hope that helps. Good luck.